Hi, this video segment is about how to read and write files in C. After this video lecture, we will be able to reach 5 main objectives. First, we will get to know two special file streams called std_in and std_out. Second, we will use fgetC and fputC for reading and writing characters. Third, we will use fgetS and fputS for reading and writing all lines. Fourth, we will use fread and fwrite to read and write all files. And finally, we'll use fscanf and fprintf to scan and print to a file. In C programming, the file stream std_in represents the keyboard, and it is the default source for scanf. In fact, scanf is a simplified version of fscanf. It requires the file stream as a first argument. Similarly, the printf function is a simplified version of fprintf that requires a file stream as its first argument. The file stream named std_out represents the monitor and is the default source for printf function. Other standard functions, which have std_in or std_out as their default file stream, also have equivalent forms, allowing an alternative file stream to be specified. For instance, f2c, fgetC, fputS, fgetS, fread, fwrite, fscanf, fprintf. These slides describe how to write and read one character at a time to and from a file. We can use fputC to write a character at a time, typically looping through a char array. We also can use fgetC to read from a file one character at a time. On the right, there is an example code on how to use fputC. We first have a main function that declares a file pointer, a loop counter variable, and initialize character array. Next, we attempt to create a file for writing to. Then we output a message to confirm that the attempt succeeded. We write each character from the array, close the file, and return the required 0 integer. Finally, we output an alternative message if the attempt fails. The fgetC is not the most efficient way to read into a program, to read text into a program, as it must be called repeatedly. It is better to call fgetS that reads text one whole line at a time. fgetS requires 3 arguments. First, a char pointer or char array to which the text will be assigned. Second, an integer specifying the number of characters to read per line. And third, a file pointer specifying where to read from. In the same way, fputS can be used to write text line by line, text line by line. fputS requires 2 arguments. First, the text to write, and the second, the file pointer denoting the file to be written to. fputS returns 0 when successful, or the EOF constant when the end of the file is reached. The slide shows how to use fgetS and fputS in practice to open and read a file and to append some text to it. Together with the usual stdio.h, we also have string.h for string functions. We add a main function that declares a file pointer and an initialize character array. Next, in the main function, we attempt to open a local text file for both reading and appending to. We output a message to confirm the attempt and succeed. And next, in the if block, we read and output all the lines from the file. Also, in the if block, we copy a new string to the array, then append that string to the text file. Finally, in the if block, we close the file and return the required 0 integer value. All files can be read with the fread function and written with the fwrite function. Both these functions take the same 4 arguments. The first argument is the char variable, where the text can be stored. The second argument is the size of the chunks of text to read or write at a time. Normally, this is 1. The third argument is the total number of characters to read or write. And finally, the fourth argument is the file pointer to the file to work with. The fread function returns the number of objects it has read. Similarly, fwrite returns the number of objects it has written. These slides show how to use fread and fwrite in practice for copying one text file to another one. We add the main function that declares 2 file pointers, a character array variable, and an integer variable. Next, we attempt to open an existing file and another file to write to. We test that both files were successfully opened. In the if block, we read the content from the original file into the character array, counting each object has been read. Then we write the content of the array into the second file. Remember to close both the text files after the completion of the reading and writing operation. The fscanf function allows us to nominate the file stream to read as its first argument. It has the main advantage when reading files containing just numbers. Remember that numbers in a text file are simply seen as a string of characters. However, when they are read by scanf, they be converted to their numerical type on the fly. Similarly, the fprintf function allows us to nominate the file stream to write to as its first argument. So fscanf and fprintf offer flexibility in choosing whether to read from std in or a file, or whether to write to std out or a file. These slides show how to use in practice fscanf and fprintf to read a file with 10 integer numbers. In the main function, we declare 2 file pointers, an integer array, and 2 regular integer variables. Then we attempt to open an existing file to read and another to write to. We test that both are successfully open. In the if block, we scan the integer from the file into the elements of the integer array. Next, we print the number of elements and write the array element values into a file. Finally, we close both files upon completion. And with these slides, I'm done. Thank you.